Good evening, everyone. Welcome to our first Wednesday lecture series. I'm Shauna Badeka. I'm the Corporate and Foundation Relations Supervisor here at the Aquarium of the Pacific. Thank you all so much for joining us here in the Honda Pacific Visions Theater this evening. This program is also being live streamed online, so welcome to our visitors tuning in there. We'd like to thank the generous sponsors for helping make this program possible, the Stephen and Brenda Olson, the Osborne and Work Charitable Trust, and Courtyard by Marriott Long Beach Hotel. I'd like to introduce our guest speaker this evening, Dr. Carson Jeffres, who will be presenting this evening on the rich history of salmon in California, our conservation efforts and our conservation efforts in place today to help and restore and recover them. I'm personally very excited about this. As Dr. Jeffres is one of my relatives, I've been hearing about his fascinating work for years, and so I'm so excited that he can share that all with you tonight. Dr. Carson Jeffres serves as the Senior Researcher, Field and Lab Director at the University of California, Davis Center for Watershed Science. For over 20 years, he has studied how native fish utilize and benefit from restored habitats, including the recovery of salmon populations in California. His research focuses on the understanding of how physical processes within a watershed and management actions affect aquatic food webs and fish habitats. He is currently working on the floodplains of California's Central Valley, looking at detrital food webs and juvenile salmon growth. His work promotes interdisciplinary collaborations with a variety of partners, including farmers, ranchers, and agency personnel, to develop innovative solutions for challenging natural resource issues. Beyond his projects in California and the Central Valley, Dr. Jeffres also has been studying spring-fed systems in the Southern Cascades, as well as rivers and estuaries in the Amazon and Southern Brazil. Dr. Jeffres earned his Bachelor's of Science in Wildlife, Fish, and Conservation Biology, followed by a master's degree and doctorate in ecology from the University of California, Davis. So please silence your cell phones and welcome our guest speaker.
Awesome. Thanks for having me here. It is, as a fish nerd, talking at an aquarium is one of the coolest things I could possibly imagine. I have my fish socks on. I have my fish belt on. Thank you, Catherine. My mother-in-law is also here who bought me this fish belt. And I was walking around the aquarium today. I was thinking, God, if 8-year-old me could see me talking at an aquarium about fish today, that's pretty cool. And so I'm so grateful to be here. And this is actually gonna be a pretty data light talk. So prepare yourselves. This is the talk that came out of a blog I wrote last year with the idea of, is California a salmon society? How did we historically interact with our fish, and how do we interact with them now? And you may ask yourselves, but we live in Long Beach. There are no salmon here. But 40% of your water comes from the Sacramento Valley. And so you also are part of this salmon society and part of this river of people who need to care for the resources that we use. And so that was kind of the idea. Is when I wrote this blog, I really was maybe at a midlife crisis or a mid-career crisis, wondering what I've been doing. And a little bit of positive reinforcement led to me to put this together, and I'll kind of take you on that journey now. So we'll start with some background, so we're all talking about the same things here. So California is a very diverse place. From the north, where most of our water falls, to the south, where it's very dry, and the amount of people is just the opposite of that. So we have, most of our people are in the south, there's less people up in the north, it's a lot more wild. And so we have ultimately developed this hydraulic society to transfer water from the northern region to where the people are at, and that has had really dramatic effects, and we'll talk about some of those as we go through. And then the other thing I want to point out here is that we also have a very dynamic climate. So within any given year, we generally have a dry season and we have a wet season. And the dry season is exceptionally dry and it's exceptionally hot in lots of places. And in addition to a monthly change, we also have this climate where we have wet years and we have dry years, and we very rarely actually have average years. So that the climate of California is very either wet or dry, and anybody who has lived here for the last 15 years has seen our exceptional dryness from 2013 through 16, and then again in 2020, 21, and 22. And then we've had wet years that followed. And that's really pretty historically normal for California. And that these fishes that evolved in this climate of both having a seasonal drought as well as these long interannual droughts has really ended up being a pretty unique situation for the evolution of the fish that live there. And this is really this idea of the hell and high water, is that when you think about California rivers, and especially in Southern California, you guys see this all the time, is that lots of time the riverbed is actually dry, and then it's followed by these rain events that dramatically change the landscape. And this is actually me here in the green shirt. And this is the Casumas River. So this is a river that flows out of the Sierra Nevada, just south of Sacramento, and it has the unique distinction of being the only river that flows out of the Sierra Nevada without a major dam on it. And that's a pretty wild thought. The Sierra Nevada is a big place. And the idea that there isn't a dam on just the one river is pretty wild. But what that one river allows us to look at and get an idea about is what does it look like before we developed everything? And so when we go look at the Casumas River here, you can see that these two pictures on the left-hand side are about 30 days apart. So we go from the top, which is the dry summer season, that actually is going into October because the rains haven't started yet. And by the time we hit the beginning of December, the water in the river has gone up about 25 feet. And that's pretty wild. And you can imagine, as a fish, you have to make a living in this place that is dry for a quarter of the year, and then is this torrent for maybe another quarter, and somewhere in between, a little Goldilocks for the rest of it. And so what's really cool about that is if you look through the assemblage of all the critters that live in California, whether they be insects, or they be frogs, or they be plants, trees, or the fishes, is they evolved to work in this climate. And they made a living for a long time doing it until we came and kind of changed everything. And you can see here, this is just an example of if you take what we call hydrographs. So really what this is time on the bottom, and this is how water flows in different types of watersheds. And then you look at, there are all these animals and plants up here that evolved to take advantage of a different part of that hydrograph. And when we come in and we change things, and we put a dam in, and we change how water flows across the environment, is we really start selecting against these different animals and plants that live on the landscape. But from a fish perspective, is they have to figure out how to do it. Is that we have these seasonal floods, we have seasonal droughts, and there's a couple ways as a fish, you can deal with this. Is that you can either get out of the system, you can head to the ocean because the ocean never dries up, or you can move up higher into the watershed where it stays cool. And we've really kind of cut that off. When we put dams into the rivers, is we cut off those migration pathways for fish to get higher up into the cool, high elevation rivers, but we also don't allow all the fish to go out to the ocean. And so that idea of migration within is really cut off, but anadromy. So the anadromy is a word that these are fish that are born in freshwater and go to the saltwater. So they're anadromous. So they make that migration and they're able to transit the freshwater to saltwater environment, which is actually really challenging from a fish perspective. And what these fish have evolved to do is that they change their bodies as they go from freshwater to saltwater. In the freshwater, a fish is actually trying to hold on to the salt from an osmotic gradient. They're trying to hold on to as much of their salts as they can. And then when they go to the ocean, they have to get rid of their salts. And so it's this process that they have to change their physiology a lot just to make this journey. And I'm just gonna walk through some of the anadromous fish that we have in California. The sturgeon. These are swimming dinosaurs. These fish have been on the landscape since before the dinosaurs, and they still persist to this day. They're cartilaginous, so they don't have bones. They're kind of like, more closely related to sharks, and they do this migration. They don't have to make the migration. Some of them can stay in fresh water. They always go back to the fresh water though to spawn. And so California has two different species of sturgeon. There's the white sturgeon, which is on the top. They don't get that big anymore in California. I would like to think that they do, but they don't. If you go up into British Columbia, the white sturgeon, is actually the populations can mix. You can get up to about 16 feet long. That's a big fish. That is a really big fish. And then our other species of sturgeon are the green sturgeon that you see on the bottom here. They don't get nearly as big. They're much smaller species. They only get to about 5-6 feet long, but they're still very cool. And I think baby sturgeon might be my favorite baby fish of all the fishes. If you ever get an opportunity to see baby sturgeon, I know it's weird to think that baby fish can be cute, but they look just like this their entire life. From when they hatch out, they look just like a sturgeon. They're very beautiful. Steelhead. Steelhead are a rainbow trout. So a rainbow trout can live in freshwater, it can live in saltwater. In Southern California, you all here are at the southern end of really this idea of the trout and salmon. And Southern California steelhead are such a cool species. They have made it, and they are still making it and holding on by a thread, living in the watersheds in Southern California. They used to historically go down into Mexico, and then as we've kind of seen this development, is their march has kind of been slowly moving north and north. And now there's some really important work that's happening in some of the watersheds in Southern California to try and bring these fish back and make sure that they persist over time. And so they are super plastic. Sometimes they'll just stay in fresh water and they won't go to the ocean. Sometimes they'll go to the ocean when they're a couple months old. And so it's this idea of plasticity, which is one of the reasons why they've probably been successful in Southern California, is that they can do a lot of different things to make a living. Cutthroat is basically the same story as rainbow trout. They live in the north coast, they live in the cold waters of the redwoods, and they do the same story. They can stay in fresh water, they can go to the salt water, but they're very plastic and can do a lot of different things. Lamprey. This might be the face that only a mother could love, or a fish biologist, because this is a really cool fish, is that they do the same thing, is that they'll stay in freshwater for years, up to 6 or 7 years, and they live as these, they kind of look like a little worm that lives in the sediment. They don't have eyes, they just have a mouth. It's like just a worm with a mouth, and then at some point in that first 6 years, they decide to go to the ocean. And they go through this, we call them transformers, that they actually look like this, only they turn bright silver on their way to the ocean, and they're beautiful. This fish was really important to the indigenous communities in California. This was very culturally important, as well as a food source that was consistent. And the native communities along the coast and in the Central Valley, this was one of the things that were truly revered for those communities, was the lamprey. The split tail is an honorary mention, just because I have to give this PSA, is that the split tail is a minnow. A minnow is not a small fish. And I think that oftentimes people think of, oh, a minnow is a small fish. A minnow is a group of fishes that can get up to 6 feet long. So under my public service announcement today, this is one of my favorite minnows in California. It's a split tail. It spawns only on floodplains. It lives in the estuary the rest of the year, so when the floods come in the spring, they leave the San Francisco estuary, they swim upstream, and they only spawn on the floodplain when it's flooded. Very cool fish. Salmon. This is where my passion lies, is with our salmon friends. We have 2 species of salmon, and I'll talk about a little bit of the differences of them here in a second. Our coho salmon are mostly up in the redwoods. They need cool rivers throughout the entire year. They spend oftentimes 1 or 2 years in fresh water before they go to the ocean, so they have to be in cold environments. Oftentimes the fog belt in the redwoods is a place where they live. And then Chinook salmon, or king salmon. Again, it might be the face only a mother could love, but I was actually snorkeling when I took this picture of this fish, and it was looking at me, just sat there and looked at me for a while, so I took its picture. And we have 4 runs of Chinook salmon in California. California is the most diverse Chinook salmon population on the planet. And you think about California, when you think about diverse runs of Chinook salmon, oftentimes your mind goes to Alaska or Canada or the Pacific Northwest. But no, California actually still has the most diverse population of salmon in the world. And it historically had one of the most abundant populations of salmon as well. The Sacramento and San Joaquin valleys, which I'll talk about in a little while, had an abundance of salmon that is hard to wrap your head around. And we see just a glimpse of that now. We see just a small portion of them remaining. And what we have is that we have these 4 runs of salmon. So we call them the fall run, the winter run, the spring run, and the late fall run. And we name them by the time of year that they come in from the ocean to the fresh water to reproduce. And one of the things that made them so special in California is because we basically had fish arriving from the ocean every month of the year, is that the indigenous communities relied on that food source, is that it was something that was reliable and predictable over time. And so those communities that lived next to the rivers, there was always a run of salmon coming in. It was a very plentiful resource that was in high abundance. And so with that, I just want to kind of make sure we're on the same story of what a salmon is and how they kind of connect the rivers to the ocean and everything in between. Is that salmon live this really romantic life story. Is that they're born in the rivers, and you can kind of see this here. Up on the bottom right is actually 2 salmon spawning at the base of Mount Shasta. Those fish, they reproduce, they lay their eggs in the gravel, they go into the rivers that are next to the mountain there, and what we call alevins, is that the eggs hatch, they are baby salmon, and they start working their way down to the floodplains, which you see in the middle here, in what was historically the middle of the Central Valley of California. It was a giant floodplain, and we'll talk about that. And then they go through the estuary, which is on the top left, and then they spend between 1 and 5 years out in the ocean, and then come back to the place where they were born. They don't all come back to the place where they were born, but most of them do. But I would be remiss to go farther without talking about the rest of our fish in California. I just wanted to touch on this because I think it's also really important. And then I'll go back to the salmon, where I think it's really fun as well. Is that California actually has very few native fish. Is that we have roughly 130 native species of fish in the freshwater environment, which is actually very few. You can go to streams in the southeast United States and find almost that many fish in a single stream. And yet that is what we have in roughly the entire state of California from a freshwater fish perspective. And they evolved in that very difficult climate that we talked about earlier, the hell and high water, is that when we had both seasonal droughts and droughts that lasted for decades, is that's a really hard place to be a fish. And so we've seen very few fish actually make it through the last roughly 30 million years of freshwater environments in California to end up with the population we have now. And a fun fact is that the devil's hole pupfish, which is a fish out in the desert at Devil's Hole, has the smallest range of any vertebrate on the planet. It lives in one spot, in one hole in the ground, and that's the only place that fish exists anywhere in the world. Smallest range for any vertebrate on the planet is in California. So we took this very difficult climate, and then we made it harder. We came in, really the development of California's rivers in the late 1800s, early 1900s. We built dams, we had hydraulic mining, what you see on the bottom left here. We built levees that disconnected the rivers from their habitats. And then we came in and added a whole bunch more competition and predation. So we're like, okay, it's already a hard place to live in California. Now we're gonna ruin your habitat and we're gonna create a bunch of competition and predation for you, which has been really challenging for California's fishes, is that we've lost 5% of the fish in California that were here historically. 5% of our fish no longer exist on the planet. We have about 26, we have roughly a quarter that are endangered, a quarter that are vulnerable to listing as endangered, and then another quarter that is, it's a concern. And then 17%, only 17% of California's native fish assemblage we're not concerned about. And I think that's a pretty tough place to be. As somebody who is pretty passionate about fish, this is kind of where this journey that this talk originated from. It's really depressing. And I know that lots of people work on lots of things. And when we see them not doing what we want them to be doing, and that's where our passion lies, is we start questioning what we're doing. And are we doing the right thing? Are we just out here spinning our wheels? Watching fish go extinct is not a fun thing to do when you've spent your life studying that fish. And similar to this baby salmon and to this northern pike right there, if you look inside the mouth of the northern pike, there's actually a juvenile salmon sitting in there. That fish is not in a good place. And I would say that the fish in California are not in a good place in general from a native perspective. So this leads me to my existential crisis. You can see there in 2002, that's when I graduated from college at UC Davis as an undergrad, and I was going out to save the world. My goal was to study salmon. I just wanted to study salmon. I wanted to be part of that system. And ever since I graduated, it hasn't been very good. I'm pretty sure this isn't my fault. I like to think it's not anyway. But there's some things that are changing. There's the things that we all hear about all the time. We have climate change that's happening. We have droughts. We have water management. All of these things have kind of compounded themselves into this perfect storm that is not good for salmon. And so really, it was about the last couple years, I was kind of reflecting on what I'd been doing for the last maybe 25 years and thinking about, have I actually been doing anything worthwhile? And I like to think I have. And I'm like, I really love fish, but it's not changing. If you look through the last 100 years, we've actually done very few management actions or restorations that are a meaningful scale. If I look through the period of my career for this 25 years, I look through the things that have changed and almost nothing had changed. And yet, we have lots of information. We have lots of people who are really well-intentioned. We spend lots of money trying to manage for these fish. And it was pretty depressing. And then my life kind of changed. This is Chief Kayleen Sisk. She is the leader of the Winnemem-Wintu tribe in Northern California. And we started working with the Winnemem-Wintu to reintroduce salmon into some of their historic habitats, above Lake Shasta, above the dams. The Winnemem, their origin story is salmon. And up until the time when I met Chief Sisk, I think I would almost think about fighting anybody who said that they liked salmon more than I do. And it wasn't until we actually spent some time together and I was realizing where she comes from is that salmon are their ancestors, and that her passion for these fish is very different than my passion for these fish. It's not that one is better than the other, but it's that we both care for them in just very different ways, and we're both trying to figure out how to get to a place that's better. And it really led me down this path of thinking about, well, how did the indigenous communities care for the salmon? How did the salmon care for the indigenous communities? And over time, how did we get to this place where California was full, or the Central Valley and the North Coast were full of indigenous communities that had abundant salmon, that cared for them and they cared for the salmon, to the time now where if I walk downtown Sacramento and I ask an average person on the street that there are thousands of salmon swimming by the river next door, they would think I'm crazy because it's not Alaska. It's California. We don't have salmon. And so how do we have that disconnection between what was once a society of people that was completely reliant on this resource to being divorced from the idea that there are even salmon that still exist in our rivers? And so I started looking back in time and thinking about how did we go through this process over time. These pictures are from near Friant Dam. So this is at the bottom of the San Joaquin Valley on the left here. There were so many salmon, they were throwing them on sticks and taking pictures of them. The picture on the right is actually from a cannery in West Sacramento. Up until 1906, West Sacramento still had enough fish that they had a cannery. Those canneries would ship fish all over the world. There was so much abundance that they would fill boats full of salmon going by, and that abundance lasted for years. And you can see what we see here is in the late 1800s, this is the salmon population. And we extrapolate these data from the canning records, is that we know that roughly the average size of a salmon and how many tons of salmon were shipped around the world that were harvested in the Central Valley. And so we have this pretty good population model of what used to be from back in the late 1800s to present. And if anybody is managing anything, this isn't the graph you want to see. But what's even worse is when you look at it compared to what we have now. Is that when I graduated in 2002, I thought that was abundance. I thought that was a time of plenty. And you can't even hardly see that on the graph. And this was really this recognition for me personally in this idea of what we lost. When there was a point in time when we had an abundance that probably everybody knew about it. Everybody knew that there were salmon in the rivers, that the rivers were important for the food and the protein that we utilized, and not only us, but the ecosystem and how that whole thing worked. And then we go to this, to the time that we have now, and I think we've really forgotten that California once was a salmon society, and that we are all very disconnected from the things that are in our areas and how we think about the rivers and how we think about the things that live in them and how they also provide for us. And so with that, I kind of went down this rabbit hole of trying to figure out, well, what can we do? If this is where we're at, this is where we were, can we have some sort of, something that looks maybe more similar to this, realizing it's not going to be the same, but can we have something that's a little more positive in a way that we can start to see it to where it's part of who we are as a people? So I just want to tell you a little bit about how our historic populations were distributed with our 4 runs, and then show you what's happened following that, and then kind of talk about ways that I think we can start showing we can get better. So our 4 runs of salmon that I talked about, the fall run, this was the reason why we had 4 runs of salmon, was that they separated in space and time. And so the fall run would come in roughly September, October, when the rivers were pretty low. And what might be somewhat counterintuitive is that when there's actually more water, it's easier to get over the waterfalls because it fills up. And so, when the rivers are low, is they could never get above this kind of roughly this area where the first waterfalls would show up. And then we had our late fall that would come in the November timeframe, maybe after the first rains had started. And so they could get a little bit higher up in the river when they started to spawn. And then our spring run. Our spring run were really the backbone of the population in California historically, is that this population would go up high into the watersheds, or would stay cool all year long, and then they would reproduce in the fall, so they could handle those warm summers because they were up so high in the watershed. And then the winter run, which you can see is the star, just the one star that's up on the top up there in the McCloud River. We started working with the Winnemem-Wintu because of that one star up there. It's the only place on the entire planet that winter run salmon evolved. Winter runs spawn in June, which you can think about in California. It seems about the worst time you could possibly imagine to be a cold water fish to lay your eggs. But one of the things that's really magical about that area is it's spring fed, is that the water that falls on Mount Shasta percolates to the ground and comes out in rivers like the McCloud, and it stays cold all year long. And so there was this evolution of salmon that evolved to take advantage of that environment, and it is also the people who lived there took advantage of that environment. The Winnemem-Wintu, this was their main protein source, were the salmon. And then in came Shasta Dam and divorced the salmon from the people, and the Winnemem-Wintu were also removed from their lands. And so part of this is bringing them back together. How do we think about that salmon society by bringing back the salmon and the people who care for them at the same time? It's not just always about the fish. We are all part of this as well. And so when we came in and we built the dams, what we did is we took all 4 of those runs of salmon that I showed that had this huge geographic area that they took advantage of, and we've tried to make them all fit in the Central Valley of California, which isn't necessarily a place where you'd probably want to have a whole bunch of salmon. We came in, we built our dams, which disconnected them from the upper rivers. But then we did something else that had a really big impact, is that this is the Sacramento Valley, and the Sacramento Valley had roughly, and some of the San Joaquin Valley had roughly 4 million acres of wetlands historically before it was developed for agriculture and cities. And this is kind of what it looked like. Everything you see here in the green is a wetland. It was a marsh, it was a tule swamp. And then what happened is when we came in and built our cities and our agriculture, this is all that remains. And we've lost roughly 95% of our wetlands. We've lost roughly 95% of our habitat for the fish. And it should be no surprise that we've lost roughly 95% of our salmon. And so with that in mind, we kind of had this idea of this is our, as a hydraulic society, has been this idea of control. We can control the water behind the dams. We can control the water in the river. We can control how we move the water throughout the state. And really, that control took out the dynamism that was there historically, took out the access to various habitats. And so what did we lose when we lost the salmon? We lost this big sense of who we were as a people, I think. And I'm going with we in this because I think we are all part of this, is that we lost our identity and our connection to that salmon, that cultural connection. We've also lost a lot of nutrients. And I mean this as a whole watershed scale component, is that when a salmon leaves the river, they're maybe a few inches long, and after spending 3 years in the ocean, they come back and they spawn and they die, like these fish here on the right. And after they spawn and die, their bodies decompose. And under the true kind of altruistic way of looking at things is that the nutrients that they bring with them from the ocean, when their bodies decompose, the algae grows. The bugs eat those algae and the carcasses. And then what's really cool about that is that when their young are born, they emerge into an environment that has been fed by their parents' carcasses. Is that by having their bodies decay, is they set up the food web for their young. And the trees that are next to the rivers, they use the phosphorus and the nitrogen. The raccoons, the skunks, the deer, the bears, all of these things relied on the salmon and what would come back in by the millions every year. So millions of tons of fertilizer were really coming back into the system that were being used. And the other thing that we lost, and part of the cultural side of it, is the fishery side of it. If you look at the fishery communities along the North Coast, as our population has dwindled, so have the fishermen. And when there's no fishermen fishing for salmon, you also lose that voice, which I think is a really important voice. You also lose the people who are selling them bait and fuel and the person at the grocery store. You lose these communities that are really set up by having salmon in the system. And that has really large just economic and social impacts as it kind of trickles through those societies. So what do we know what we've really lost? I think that's one of the things that's really been challenging for me is trying to understand what is not here anymore. And it's really been my work with Chief Sisk. When you really want to be humbled as a fish biologist, spend some time with some indigenous communities who have been working with salmon for generations, and then you'll feel really humbled. When we first started working with Chief, in California actually has something pretty unique in that almost all of our fish go to the ocean a couple months after they're born. As you go farther north, you see that salmon will stay in the freshwater environment for a year or 2 or 3. And we said, no, we study this. California salmon go to the ocean in the first couple months. And Chief said, oh, no, they don't. Some of them will stay, some of them will go. And that's how they diversify their portfolio. And with that kind of thought in our mind and understanding what happens in drought, is we started looking through the ear bones of the fish and understanding what that actually meant. We also go through the eye lenses of the fish. So the ear bones of the fish are the otoliths. That's their travel journal. So when a fish is born in any given river, they incorporate the kind of the chemistry of that river gets incorporated into their ear bones, which is the picture of an otolith up there. It kind of looks like a tree. If you take a cross section of a tree, it looks kind of like an otolith. They put on a new layer of that otolith every day, and then we're able to track their migration through the chemistry of each of those layers through time. And then the other thing that we've been trying to figure out is their food journal. How do the food opportunities change over time? And what are some of these historic habitats that they had opportunities to access? And for that, we use the eye lenses, which are kind of like an onion. Is that as a fish's eye grows over time, because when they're born, their eye lenses are super, super small. They're about maybe 1/4 to 1/10 of a millimeter. And then by the time they're a large adult, they're maybe 1 centimeter. And so over time, they put on these individual layers. And what's cool is that under the you are what you eat, so I saw there was some wine and some beer out here today, you're gonna look isotopically like the foods you eat and drink. And we use that same idea that the fish eye lenses represent the diet journal of them. And I'll talk about each of those right now real quick. So we have this map of the different strontium elements. Strontium is an element, we look at the isotopes. And when we started looking across this idea of seeing like how long does a fish stay in each of their individual rivers. So we take the otolith out, we see the little laser spots there, is we have a little laser that goes and shoots a spot and we suck up that gas and we can tell the isotopic ratios that are in there. And then it tells us how long they actually spend in any given river before they go to the ocean. And what we found is that really the same idea that Chief Sis told us was that, oh no, in the droughts, it turns out that they don't all go. So what you see is the early and the late there and the intermediate. The late fish are fish that spend at least 1 year in the river before they go out. This was a really impactful paper because what we realized was that, oh, there's a lot more diversity than we thought, one. But two, this is also kind of the Hail Mary that the salmon throw out there, is that by saving some of them behind and not going out to the ocean during a drought when conditions are bad, sometimes that's actually the strategy that wins. And the idea of diversifying your portfolio across a lot of different strategies is really the thing that have made salmon successful for tens of millions of years. And so it's kind of like seeing us, like when you don't know what you've lost, it's kind of hard to reimagine what it can be again. And really having somebody push us to question those ideas has been really valuable. And then from a habitat perspective, this has really been much of my career to this point, is that trying to understand how fish move across the landscape on their way out to the ocean. Is what you can see here is these fish up on the cooler on the left. I've made a career out of this picture. This picture comes back to me all the time. People present this picture to me, in fact, without my name on it, which is always interesting. But what this was one of the first insights into what a floodplain means for a salmon in California. And these fish are actually the same age, in that the fish on the right had access to a floodplain, the fish on the left were in that levied river. And this was really this kind of one of those eye-opening moments of like, holy moly, we've been doing this wrong for a long time. We've had this idea that fish need to stay in the river and not understanding what a river is when it actually spreads across the landscape. And so you can see on the bottom here, these are two beakers with the same amount of area sampled. You can see the one on the right is actually full of zooplankton. That's fish food. That is the difference in food resources on a floodplain versus a river. And I know it sounds crazy, like, oh, we got to get the salmon out of the rivers. That's what we got to do. And it took a long time. It's taken 20 years for us to get there. We're just starting to make some of those changes now, and I'll highlight one of them here in a few minutes. But what we can do is we can actually take the islands of those fish, and then we can look at them, we peel them. I have a whole group of undergraduates who peel islandses, which is a very character-building job. I'm very, very grateful for them, and they're very good at what they do. We can analyze the isotopes for those, and we can see whether those fish had actually fed on a floodplain or whether they were just in a river. And one of the things that you can see is that this is the Sacramento Basin here, is that you can see different rivers have different opportunities and different habitats, and we can start to reconstruct what that looks like. So it helps us have this idea of that when we look at how juveniles recruit to adults, if we know which habitats those fish use, then those are the habitats we want to try and restore and try and reconnect. So I think of our system as a patchwork of habitats, is that some of them are levied like the bottom right here, some of them look more natural, and the idea is that if we can understand which of these is ultimately taking juvenile fish and making more adult fish, then those are the things that we want to try and highlight and the things that we want to try and move forward, because we didn't know 25 years ago that these habitats were important. These are things that we didn't appreciate. And through this process of learning, we're trying to figure out what we actually have lost and reconnect some of those things. So where do we go from here? We know pretty much what our past was like. We know what the habitats were like. We knew from lots of the descriptions, the early settlement of what the kind of, this is just of the delta, but it's a good representation. We know what we have now. And we're hitting this point now where we need to start deciding what we want to have for our future. And I think that this is where the work that I'm doing now is deciding, what do we have? What do we pass on to the next generation that maybe wasn't passed on to us? So I gotta give you some good news, because I'm sorry, this has been depressing, but I wanna talk about something happy. Is that this is the story of Puda Creek. Puda Creek is the creek that flows through UC Davis on the bottom there. And in the 90s, UC Davis as a university and the city of Davis sued to change the way that Poudre Creek was managed. Poudre Creek is a heavily impacted system. You see Lake Berryessa here on the upper part. It's used for urban and ag water. And there's no passage above what we call the Poudre Creek Diversion Dam there. But we thought that it could be different. And so we proposed this change. This isn't what it looked like historically. This isn't what it looked like in the last 100 years. But we thought that this could be something that could provide meaningful change that would both attract salmon into the river and also get them out as juveniles and provide a much more, that circle of life of the salmon. And I'll spend a quick second talking about what we see here. So in 2016, which is on the left here, the fish started coming back because there were no salmon in Poudre Creek. But when we changed those flows and provided an opportunity that looked more like it did historically, is fish started coming back. And that romantic idea of salmon always going back to the place where they were born, it's a little exaggerated. And that fish actually stray quite a bit. When we first started looking in 2016, there were no fish that were actually born in Poudre Creek that came back to Poudre Creek. And Poudre Creek is the yellow color that you'll see on the bottom of the 2017. Only one fish that we caught came back that was actually born in Poudre Creek. But what you can see is in 2020, we had one, but by 2021, we had 9. And I know that doesn't seem like a lot. 9 fish does not seem like a lot of fish coming back, but it's more than 0. And it's a start. And the thing with salmon is their generation time is roughly 3 to 5 years. We shouldn't expect our challenges to be overcome in 5 years. This is a process that takes decades. And we shouldn't be judging success or failure in a short time frame, but the fact that we saw 9 fish come back is really one of the coolest things I can imagine. And what's even better is in 2025, we had 2,100 fish come back. And so when you give them a chance, they start to come back. You have to provide the conditions for them to come back, though. And part of that is doing restoration at scale. So this idea is, you can see where UC Davis is again there. This is the Yolo bypass. This is the largest flood control infrastructure in the state of California. It's about 40,000 acres. And it is a place that saves Sacramento in 2 out of 3 years. Without the Yolo bypass, the city of Sacramento would not exist because it would be inundated in a Katrina-style event every 2 to 3 years. And that's not sustainable for the world's 4th largest economy's capital, right? And Leland Stanford took a rowboat down Capitol Avenue for his inauguration. And that's why this system was built. You clearly cannot imagine Newsom going down Capitol in a rowboat. We've moved on, we've changed. And so realizing that, how do we take advantage of this structure? And so what you can see here on the top, this is a structure that was built into historic infrastructure that was built to save Sacramento. And what it is, you see those big gates on the top there, is that now allows flows from the Sacramento River onto the floodplain more frequently. What used to be every maybe 2 out of 5 years, we will see fish out here every year now. And that's a big difference. It's a large infrastructure change. And then on the bottom here, in addition to that, allowing fish out into the floodplain, we're making more floodplain. This is a 1,000-acre project that was actually primarily conducted for flood control. And we saw that and we're like, holy moly, that's not flood control. That's like floodplain magic. Is that what you see here on the right side is we throw a little net out in the water and we return it back. And when I showed you the zooplankton that were on the floodplain that made those big fat fish, that's the food that lives out in that habitat. And so when you reconnect the habitat and you start doing restoration at the scale of thousands of acres, it's great to do restoration on the acre or the 10 acre, the hundreds of acres. But when you actually start having meaningful restoration at a scale of thousands of acres, that's when we start to see change. And then this is the intertidal restoration at the bottom of Yolo bypass. This is a 2,000 acre restoration as well. You can see this, what you see on the Liberty Island Ecological Reserve. It's actually a lookout slough, but we recarved in. You can see kind of the remnants of what used to be the agriculture. You can see some of the squares still on it. But you also see the curvy parts of what is now an intertidal estuary. And so when we start doing these things at a meaningful scale, this is when we start turning this ship. This ship has been going one direction for 150 years. And how do we start slowly turning that ship? I think one of the things that we have to do is think about how we have art in our society. I will say Long Beach dominates Sacramento in this space. I saw rays on the sidewalk. I saw fish in the crosswalk. I saw whales, little metal whales my the sidewalk. That is how you recognize what are the things that you value in a society, is the art. My daughter plays golf, so I get to hang out at golf courses a fair bit. And they just redid their clubhouse and they put salmon on. That's pretty cool. The Sacramento airport, I am determined, is the most depressing thing that I could do these days. Is that whenever I fly in and out, I see this river on the floor. This river shouldn't represent who we are. It's a dead river. There's no life in that river. And my goal in my career is to have art that represents who we are. When people arrive to Sacramento, they know who we are as a people. If you fly into Seattle, you fly into Vancouver, you fly into Portland, what's on the floor? Salmon. Salmon is on the floor because they still identify as a salmon site. There's also lamprey and sturgeon on the floor if you're really interested. They really are into the whole ecosystem, and I think that that's really important. And so when I think about remembering a salmon society, when we kind of go through these things, I really think our art has to be part of it. Our art says who we are as a people and where our values are at. Having a dead river in the middle of an airport, that shouldn't be how we value that space. It shouldn't be what people see when they first arrive and think about where they're arriving. Food grows where water flows. Anybody who's driven down I-5 has seen these signs. This is a sign from the San Joaquin farmers, and yeah, they do need water too. But I will also say, from an ecosystem perspective, is hell yeah, food grows where water flows. That's where you see production happen. This is also important. It's yes and. We're never getting rid of our economic engine that is our agricultural communities. And I think that's really important because we need that food, but we can do it better. And so remembering how our priorities, it's not just ag water, it's not just municipal water, but how do we make it ecosystem water at the same time? And I think there's a lot of ways that we can reimagine that. The next generation. Our youth are arguably the most important thing here. We do a bunch of work with Indigenous communities up in Canada that are in the Columbia River above the dams. They have been without their salmon for 2 human generations. So when Grand Coulee and Chief Joseph dams were built, they lost their connection to the salmon. One of the things that they have the biggest challenge is bringing their next new generation of people into the salmon. They have kids who have never seen a salmon in the wild before. And so they spend so much of their effort educating the next generation, teaching them how to process salmon, teaching them just how to release salmon like these kids do. I have the absolute privilege of working with high school kids in our area and having them have a connection to the river. Most of these kids have never been to a river before, and they live within 10 miles of one. It is unbelievable, but it's also unbelievable to watch how invested they get. And I think that if we really want to do this in the future and have a successful, really, it's not just about salmon. It's maybe salmon are the flagship species that kind of is a better representation of the ecosystem, but it can't be just a bunch of middle-aged white guys who advocate for it. And I genuinely mean that. And that if we don't bring everybody along, then we won't get there. And I think part of this has to be with the Indigenous voices as well. I know it's fundamentally changed how I value the work that I do and the communities that I get to spend time with and what I have learned. And I am a better Western scientist from my relationships with the Indigenous communities that I've worked with. They've made me change the work that I do. And it's amazing, from things that we've built fish viewers to keep fish in water now because the tribe hated that we as Western scientists took our fish out of the water and we'd put them on a board, we would measure them. They said, we hate it. Those are our ancestors that you're taking out of the water just to get a measurement. And I remember the day that Chief asked me, why do you do it? And I said, because we always have. And then I caught myself. I said, that's the worst answer I could ever give you, because we always have is not the answer. And we've innovated in that space, and now we measure our fish in the water, and we get more data from them. So from that insight and pushing us to do better, we get more good data than we did before. And I think just having those voices in that space is something that I cannot place enough value on. And also just, I think it's the right thing to do. And this picture is actually taken on the Klamath River, where the largest dam removal project in the world took place on the Klamath River. It was driven by the indigenous communities that lived on the Klamath River. For generations, they fought the dams. There are generations of people who are no longer alive who fought, who never got to see this day. And this is truly one of the most magical things I can tell you about, is that within days of the dams being removed, salmon passed the dams and went into the historic waters that they were in. The fish are resilient, you just have to give them a chance. So what does our future look like? This is a map of the Sacramento area in the late 1800s. That's not our future, that's our past. I think we have to be very eyes wide open about that. We are not going back to that system. It's too developed, there's too many people, it's too much agricultural, there's too much people, there's just so much going on. But it doesn't mean that we can't try and restore the processes. Realizing that there's so much more we can do to restore those processes. I talked about the reconnecting of the floodplains. Think about how we manage water out of dams. We can still move water all over the place. We can do it better, though, than I think we're doing it right now. And it's really going to be a diversity of habitats that does this. Some of them are going to look like flooded rice fields. Some of them are going to look like natural floodplains. Some of them are going to look like chaos, because this is actually what a river looks like. A river is a chaotic place. And I think this is a quote that has really motivated me a lot, is that it takes a river of people to bring the salmon home. We are all part of the river of people. The rivers of California get transported to Southern California. You're part of that river of people. This is part of our watershed, whether it's something that you just recognize outside your door or when you turn on your tap. We are all part of this community, and I think we all, as part of users of this resource, have an obligation to think about how we use it, but also how we prioritize the things in our environment. If you have time, this is a great 30-minute video to watch about bringing salmon back up in above the dams in the Columbia. It's really moving. And I'm going to close with this. This is a quote from Tom Philp, who is our writer for the Sacramento Bee. And he put this in a series of articles that he wrote, and this was his closing kind of argument. And I think that this is really moving. I read this, and I was like, oh my God, Tom, I'm putting this as my closing slide. Because I think this really represents not only the salmon, but lots of the things on the environment. Fewer of our native residents, whether they be people, or whether they be plants, or whether they be animals, is that thinking about these things that were historically here, we can still have our Yosemite Valley. We can still have our Lake Tahoe. We can still have the ocean. But the things that once inhabited this place were important and still are important, and it's all of our responsibility to look after them. And I think that's what I'm going to close it with.
Thank you so much for that. We have about 10 minutes for Q&A. So our volunteers are here in the aisles with some microphones. Please raise your hand and they'll come bring you a mic and ask your questions.
Yep.
Hi. Thank you so much for your talk. It was really interesting to hear the community aspect of it. My question is, I'm still thinking about those 26% of endangered species. With increasing water in our floodplains, are we seeing benefits to them as well?
Yeah, we are. I mean, so every species, of our 26% of endangered species, all of them actually have a different need, and there's a different reason. The work that I was talking about with the floodplains is it definitely helps and benefits a portion of those, particularly the salmonids, the split tails, the sturgeon, those types of fishes are benefited from that. The rest of them have other threats. And so whether they be water development or drought effects or fire, the ecosystem is so complex, there is no one thing. is that I think we all would love to have a silver bullet, that one habitat. It's just going to be floodplain. But the reality is that there's so many different parts of it that there is no one silver bullet. It's just one of them.
Thank you.
Thanks, great presentation. My question is related to, so we have the Endangered Species Act, right? It's a regulatory framework we can use to adjust behavior. Right now, my understanding is that's been focused on the Delta smelt for control of floodplain management in the Central Valley. If we are managing the Delta smelt well, is that going to also mean we're going to manage the salmon better? Do the salmon need habitats further upstream? Can we kind of rely on that? And my second question is, what's going to be the impact of the California State Water Project improvements on the salmon?
Boy, there's a lot there. So the Delta smelt are a small fish that is endemic, so it's only found in the Sacramento-San Joaquin Delta. There are almost none of them left in the wild, and that there's a lot of work to try and bring them back. I mean, I'll be honest, it's a tough road to hoe, is that because of the change in the habitat, the invasive species, it's really challenging. I would actually say that the salmon benefit is probably more helping the smelt than the smelt actions helping the salmon, because the smelt almost are all exclusively downstream of the floodplain habitats. They're really a delta-focused fish, where the salmon, all of that nutrients actually comes into the delta. So we see the benefits, like when the floodplain is wet, that food resource ultimately enters the delta, and we see that whole delta ecosystem benefit from it. It's gonna be a tough go for the smelt, I'll be honest. As somebody who is very passionate about fish, it might be really hard for them to be there in the long term. Second question was, how does the State Water Project, so there's the Healthy Rivers and Landscapes program. I don't know if how deep we want to go here, but there is a whole effort right now in the State Water Project, realizing that we have to have water security. Water security is really tied to ecosystem function in a really weird way, in that when there are fewer salmon on the environment, then more water restriction is actually placed on it, whether they be municipal water users or agricultural water users. I get to sit with this group now that is a group of commercial fishermen, farmers, and water users, and they have all realized that salmon are important to their water security over time. And so we've started to make these big actions. Like what you saw with the change in the notch in the weir that floods the bypass more frequently, that's a State Water Project funded action. And so it is these big landscape scale things, and I think that it's really yes and I can't say that enough, is that we can't do this fighting over regulation and regulatory action. We have to find a place where it's like, okay, I'm willing to give up here, you have to give up here, and we have to find the place where we can at least have the conversation to manage better. And that is the place that I think has changed in the last year, 2 years. I actually have some hope again. 5 years ago, when it was just lawsuits and fighting, and we don't get anywhere under that sort of environment.
Thanks for the interesting talk. I know it's difficult to talk about the policy and management of natural resources without talking about politics. As a fellow fish nerd, that executive order that came out last year, prioritizing people over fish, really felt like a gut punch to me. I don't know, do you have anything to say about that narrative being pushed and how that's affected your work in conservation?
No, and which executive order, by the way? For the federal one? Or?
Yeah, the work in Sacramento, prioritizing.
Yeah, there's a couple of different parts, and that might be a whole nother lecture series. We could do a whole series on that. Politics and management are complicated, but it ultimately boils down to people. And I think that there was the executive order from the feds that was, I would say it was a gut punch for lots of us as well. But we live in California in a place that is very dynamic in its governance. And I think that there's a lot of push and take there, and that when one of them pushes, one of them can take and we can go back and forth. It actually wasn't as dramatic as it could have been. I think we could have had a lot more challenge in that space. And I think the ability of the state to kind of work through that in a way that is different and work around it gives California a unique perspective in that spot to try and still prioritize some of the actions that we're doing. That notch that I showed where we connected the river to the floodplain, that was roughly, those things are still happening. That was hundreds of millions of dollars that were spent in that action for the fish. And an executive order prioritizing people over fish isn't going to affect the management of that. So I think we're still seeing these things go forward regardless of that challenge that we're seeing in some of those orders.
Hi, thanks for your talk. I was wondering if you could talk a little bit about the role of hatcheries in the recovery of these populations and maybe what they do well and what they could do better.
That is such a good question, and that could be a whole nother talk. Everybody heard it. So hatcheries are, I think it's the domestication of our fish. In the same way that, if you have fish in a hatchery for a long period of time, would be like taking cattle and releasing them out in the wild. They're not always as prepared for the wild as they could be. I think that there's been a lot of changes over our hatchery management, particularly over the last couple of years. With the advancement of some of the genetic work that we're able to do, is that the parental-based tagging. So it's basically 23andMe now, is that all the fish that come into the hatchery, we actually know who their parents are, and so we can look for them in the future. And that has allowed a lot more flexibility in the hatchery system. My goal is to not have a hatchery-supported population. I think we need them for our near-term planning. And when I think about this, I have left the what's happening in 10 years plan. I've gone to the 100-year plan. In that, because of the generation time, because of the slow process of change, it takes generations to get from here to there. And I think that if we can lay out a good plan to realize that they're important for us now, but it might not be our future, or they might have a role some way in the future, but having be totally reliant on hatchery populations doesn't benefit any of the wild stocks that we see. And we're seeing change in how that's happening right now. I think we are seeing positive changes in that space. Yep.
And we have time for one last question.
Oh, wow. Okay. Thank you again for your talk. It was very inspiring. I know that barring removing the dams outright, what kind of engineering solutions do you think could play a role in growing these salmon populations? And then specifically the idea of salmon ladders to help the salmon kind of bypass the dams outright. Thank you.
Yeah, so we're probably not removing our major rim dams in the Central Valley just because of the flood control reliance and the water delivery reliance. The dams, the main dams like Shasta, Oroville, Englebright are actually so tall that it's actually really challenging to get a fish ladder over. Fish ladders would be tens of miles long to get over a 700-foot tall dam. And so in the work that we're doing, we're trying to figure out ways to collect adults, collect juveniles, and in the short term, by short term I mean the next 50 years or whatever that looks like, is try and diversify those populations by either what I'm calling assisted migration, like we help them above and below the dams on their migration, to diversify. We need more eggs in baskets. We can't be reliant on the populations below the dams. And the other part of your question is what are some of the other things we can do, is remanaging how we release water from the dams. I think that is a big one, is that we ultimately turn the knobs on the entire system, is that there's somebody who controls water releasing out of a dam every time. So we make the decisions on how it happens. How we prioritize that water and ways that we can use it in multiple ways is really where the rubber hits the road under a novel management future that I think we're just starting to get into ideas of how we can think about that.
Yes, let's certainly give Dr. Jeffres another round of applause. Thank you so much. I just want to also note our next First Wednesday program on April 1st will be on owls of California, presented by renowned nature photographer Paul Bannock. The lecture information will be on the website, and we hope to see many of you there. But for now, we invite you all down into our art gallery for conversation, cocktails, music, and crafts. And Dr. Jeffres will be out there for many more of your questions if you have them. And we ask that you all exit toward the bottom. Our upstairs is closed for construction for another exciting exhibit opening this summer. So hope to see you in the gallery now and then next month as well. Thank you.